we're going to start talking about the three types of forms of lines that we're going to deal with. The first one's called the point slope form, and this is basically the equation of a line with the slope of m and passing through the point x1 comma y1. This is given by the equation y minus y1 equals m times x minus x1. Notice I've highlighted in green the slope and in red the point we're going to plug in. We could also write it in this form where we have y equals m times the quantity x minus x1 plus y1. We will write it occasionally in this form if we want to write it in function notation, because remember, function notation just replaces y with f of x. This is used specifically when I have a slope and a point, hence the name point slope. An example of this is write the equation of the line passing through the point 4, negative 5 with slope of m equals 7. We're going to take our equation, y minus y1 equals m times x minus x1. We're going to plug in negative 5 for y1, 7 for m, and 4 for x1. What we want to do is to distribute the negative over here on the left-hand side. We get y plus 5 equals 7 times x minus 4. We could stop here. Please realize this. This is actually right now in the form, the point slope form. We could stop here, or we could carry it one step forward and bring the 5 to the other side. We could get y is 7 times x minus 4 over negative 5. Remember, these are both point slope forms, and they're both equivalent to each other. Second form we're going to look at is what's called the slope-intercept form of a line. Again, we're going to define this to be the equation of the line with the slope of m and the y-intercept of 0 comma b. Again, I've highlighted the slope in green, m, and b is the y-intercept. We've already looked at examples of this in some of our prior lectures. This example says, write the equation of the line passing through the point 0, negative 5 with the slope of m equals 2. Now we do know the point 0, negative 5 is the y-intercept because the x-coordinate is 0. Again, by definition, a y-intercept is where x equals 0. So it's not just a point we have here. We have a specific point. We have the y-intercept. You cannot plug any point in for b. It has to be the y-intercept. It has to be where the x-coordinate is 0. So when I go to write the equation for this line, this is simply y equals mx plus b, or y equals 2x minus 5. There's a third form for a line called the standard form. This is the form that has ax plus by is equal to c. Here, a, b, and c are integers. In other words, there's no decimals or fractions. If we have decimals or fractions, we multiply both sides to get rid of them. And typically, a lot of books will require a to be positive. So it's not positive. We multiply everything by negative 1 to make it positive. Please note, while the rest of the problems had all the colors that I highlighted we plug into, we will never plug into standard form. Okay? We may manipulate and get standard form at the end, or we may start with standard form and move it to point slope form or slope intercept form. We will never plug in directly to standard form. The question is, how do we get equations for lines? There's one basic concept that we need to grasp. To get an equation for a line, you're always going to need two things, a point and a slope. And I will bring you through a few examples of these, and we will check to make sure we have the point and the slope. Now, once you get both of these, you'll need to plug into either one of two forms. We showed three forms. Again, we'll never plug into standard form. You plug into either the slope-intercept form or the point-slope form. The only time you'll plug into the slope-intercept form is when you have the y-intercept. Let's start with an example. Find the equation of the line passing through the points negative 4, 5, and 2, 3. We ask ourselves simply, do we have the point and the slope? Well, the answer to the point is yes. We actually have 2 points, but we don't have the slope. So what we need to do is we need to solve for the slope. Our formula for slope is m equals delta y over delta x, which is 5 minus 3 over 2 minus negative 4, which gives us our 2, 6, which reduces to 1/3. So now, after this question, do we have the point and the slope? Our answers are both yes. Now, we have two different points. We can choose either point. I'm going to choose the second one, the 2, 3. So I'm going to plug into the point-slope formula. I need to plug into this one because I do not have the y-intercept. This is simply y minus 3 equals 1/3 times x minus 2. Our next problem. Again, find the equation of the line with x-intercept negative 5 and slope 1/2. Do we have a point? Yes, we were given the x-intercept. Do we have a slope? Yes, we do. We're given the slope of 1/2. Please note we're given the x-intercept, not the y-intercept. The x-intercept is where y equals 0. The y-intercept is where x equals 0. So we have to treat them differently. So we're going to plug in y minus 0 for y1, because this point that we have is actually the point -5, 0, equals 1/2, that's my slope, plus x. Since the x-intercept is -5, a minus -5 becomes plus 5. Now we could leave it in this form, or we could actually distribute this 1/2 and kind of drop the 0, because the 0 is not going to affect anything. And we get y as 1/2 x plus 5/2. Notice this is now in slope-intercept form, and the 5/2, this is actually our y-intercept. Alright, let's look at an example. For children between ages 6 and 10, the height, y, in inches is frequently a linear function of ht in years. The height of a certain child is 46 inches at age 6 and 48 inches at age 7. Since height depends on age, height is our dependent variable, so it's our y. Age is our independent variable. This actually gives us 2 points. It gives us the point 6, 46, and the point 7, 48.5. So we ask ourselves, do we have a point and slope? Yes, we have a point. No, we don't have a slope right now, but we have 2 points, so we can use our slope formula, our delta y over delta x, and that's simply 48.5 minus 46, all over 7 minus 6, which reduces to 2.5. Now I have my slope. I'll pick either point. I'll pick the one without the decimals. So y minus y1 becomes y minus 46 equals m times x minus x1, which becomes 2.5 times x minus 6. Now with this equation, if we were to actually solve for y, we can use this equation to predict the child's heights at age 8, 9, or 10. We can't go beyond age 10 because we said this only behaves between the ages of 6 and 10. So once we go past age 10, we have to assume that this does not behave as a linear function. The next topic we want to look at is graphing lines. And to graph a line, you simply need 2 points. Let's look at an example. Graph the following equation by plotting the x-intercept and the y-intercept. We have 3x minus 4y is equal to 12. By definition, the x-intercept is where y equals 0. So if I take our standard form for our line, plug in 0 for y, we get 3x minus 4 times 0 is 12. So simply 3x is 12, so x is 4. So please be careful when you're doing this, because a lot of students will solve this one and then solve this one, then put them together into a single point. We're going to be solving 2 different points. We were given y is 0 here, and x is 4, so this is the point 4, 0. Now this one over here is a separate problem on the right. The y-intercept is where x is 0, so we plug in 0 for x. We get 3 times 0 minus 4y is 12. So negative 4y is 12, so y is negative 3. So this gives us the point 0, negative 3. I now have 2 points. To actually graph this, basically all we have to do is plot our points. So we have the point negative 3, 0, and 0, negative 3, and 4, 0. We plot the points and connect the dots and draw our line, and that is simply our graph. We have a couple more concepts before we wrap up this section. The first one is a vertical line. A vertical line by definition has a slope that is undefined. The reason it is undefined is when we have our delta y, we have a delta y which changes, but delta x never changes. Delta x is 0. So when we divide by 0, that means that we cannot do that, so it is undefined. Now the equation for a vertical line is x equals c, where c is a constant. In this case, this example is x equals 5, because it passes through the x-coordinate of 5 with every point. Horizontal lines behave similarly. A horizontal line has a slope that is 0 since delta y is 0. Notice on this graph, delta x changes, delta y never changes. This graph never goes up or down from point to point. The equation for a horizontal line is y equals c, where c is a constant. In this case, it's y equals negative 2, because every point on this line has a y coordinate of negative 2. parallel and perpendicular lines. I'm not going to speak a lot on parallel lines. These lines by definition never cross, and therefore they have the same slope. Perpendicular lines behave slightly differently. Okay? Perpendicular lines cross and form a 90-degree angle. Notice if I'm looking at the slopes of perpendicular lines, notice the rise on the blue line is A, where the run on the red line is A. Notice the run on the blue line is B, and the rise on the red line is negative B. What this simply means is that perpendicular lines have slopes that are negative reciprocals. Well, negative just means you change the sign. Reciprocals means you flip. So if I want to look at an example of two lines that are perpendicular, they would have slopes. In this case, an example would be 2 and negative 1/2. Notice I'm going from a positive to a negative, and I'm flipping it. So these are examples of slopes that are negative reciprocals. Similarly, negative 4/3 and 3/4. Again, I'm changing the sign and flipping it. Let's go back to our examples of finding equations of lines. Find the equation of a line that's perpendicular to y equals negative 3x plus 5 and passing through the point negative 4, 5. I have the point right away, I don't have the slope. But the slope of the line I'm given, this y equals negative 3x plus 5, this is y equals mx plus b, this slope is negative 3. I'm told the lines are perpendicular, so the slope of the line I'm looking for, if I take this negative 3, I change the sign and flip it, the slope becomes 1/3. We now have our slope and our point, so we're going to plug into our point slope form. So y minus y1 equals m times x minus x1, so y minus 5 equals 1/3 times x plus 4. Again, the x1 and the y1 come from the point, the 1/3 comes from the slope. Our last topic is direct variation. We say that y varies directly with x if there exists a non-zero constant k such that y equals kx. In other words, y is considered the constant of proportionality or the constant of variation. Notice this y equals kx. This is basically a linear equation, y equals mx plus b. We use k instead of m because we want to categorize this as a specific type of function, but your b is understood to be 0 here. An example of this would be sales tax. The sales tax y on an item varies directly with the price of an item x. If the sales tax on $95 is $7.60, find the constant of proportionality. We know if it varies directly, that means we know we have the situation y equals kx. So we want to find k. We know that the y is the sales tax, so 760 equals k times 95. So k is 0.08, which sounds reasonable because our sales tax should be somewhere around 8% to 10%, depending on where you live. And the sales tax on $210 item, well, if we take our equation again, we knew what k is now. Y is 0.08 times 210, so our sales tax should be $16.80.